Hello everyone. So, can everyone hear me? So just message in the chat if you are able to hear me. And so, okay, cool. So I'm muted everyone, intentionally because sometimes it's easier to conduct the chat session. So this will be a short session. I will try to make it short, and you can, paste any of your queries or anything you want to discuss in the chat box. And in the end, I will try to, unmute everyone so that, if you have any queries, you can quickly ask them. So this is a recent question, which was asked in a Google interview, which you see in front of you. So I believe everyone should be able to see the screen, which I'm sharing. And this was for SD1, and this has been similarly asked for SD2 position also in for the position of software development engineer and Google. This is the first round. You can go over the question and maybe take a minute or two to go over the question and maybe if you have any ideas how to go about solving it, you can message in the chat and I will present the solution, which actually work for this and which help the candidate to move to the next round. So any ideas if you have, you can share in the chat. Yeah, Q seems to be a decent starting point. Also, the question, if you see, it's like it requires some clarification, as somebody mentioned, that what data is required for each party, like some kind of ID. So that's a good starting point. So, like even if you are supposed, post like this type of question, so as you can see, some things are not very clear in this, like a party of customer. What do you mean by a party of customers? So the interviewer in generally this kind of interview doesn't give you all the details initially, and he expects you to ask a lot of questions and so that while you ask question and then the interviewer will reveal more details. So one thing that one of the person Peter, he asked, well, what exactly data is required for each party. So in this question it's not given, and the interviewer will also post this exact question like this, but when you ask it is the interviewer can guide you. Now a party of customers means, so there could be like suppose 10 team members, or if you think imagine they are going for a actually going to a restaurant for a party, and so they are waiting in the queue. So the queue concept also comes in because suppose there is a waiting list, the person who comes first obviously will get a chance to get a table first. And so it's like when the person, there is an empty table, then the person at the head of the queue, he can leave the queue and take occupy the table if given that. So third point, if you see, he can only occupy the table, there is a table available of that size. So like if there is a group of 10 people, but the table that just got empty is of size 5, then it's not possible for those 10 people to occupy. And then in that case, what we have to do, we have to see the next person who is there in the queue or who is there in the list, and see if it's possible to accommodate that particular party. So if you, so you can, in this case, one example is we can, so party, if you see, there will be a lot of, so party consists of a group of people. So for simplicity, we can assume, there will be like a set of people. And we can also, we need generally it's a common practice to make an identifier to assign to a party. So, we can assign an ID to the party. So this ID will be towards the for the party, not for the particular people. So if a group of friends from a company A comes and there are 10 people, so I can suppose assign the ID of that for that particular party, company A, and the group of people will be like whatever, say people name. So this is the first step. Uh, Another first step or the same step I will say, or the second step is to identify that it requires some sort of queue. And the first step is also to to clarify with the interviewer like what this party is, and and then come up with a data structure or at least a class. So I will be coding in Java, but it will be very similar in other programming. You can easily convert it to any other programming language because this is more question of like an object-oriented design, a little bit of object-oriented design, and also it has something to choose the appropriate data structures to or perform all these operations in the most optimal way. So party will obviously have an ID and a set of people. So in Java, you can simply define a party class and assign it some integer ID or anything, and just so by set of string of customer, I just mean that, or it can be a list of customer also. It doesn't matter, whatever data structure you want to use. I don't think it matters here what you want to use. So, the ID also, it doesn't matter whether you want an integer or whether you want a string ID. All it matters up till this point is for you. The interviewer expects you to identify these two things. That since it's talking about party, it's not talking about a single person. It's talking about a group of people, and you need to assign that group of people to a particular table. So the only way that you can assign a group of people to a particular table is now later on. How do you refer that? Okay, which group of people have you assigned to say table number one? You need an ID. You cannot say that I have assigned the person one name, comma person two name, comma person three to this particular table, unless you make that kind of comma separated string and ID. So, so first step is to come up with this kind of class. It can be anything. It doesn't. In this particular question, the interviewer didn't expect. It can be this can be an integer, this can be a list, this can be also this can be generally like the name of the customer. So this part is the one important part to clarify, because unless you hit this part correct, you will not be able to proceed. So 1% on multiple queues for every possible table size. No, you won't require that because you will come to know the problem is doesn't need multiple queues. And so first thing I just want to ask if this part is clear to everyone. Why do we need to do this? And you see the significance of designing this class. With any questions for this, you can just message in the chat. Why the need for ID? Why the need for storing this set of customers? Okay, so it should make sense. But in case you have any question towards the end, we can go over that too. So now let's go over. So I will present two different type of solutions. So we'll go with the one naive approach, which is also good, but because once you hit a single solution, it's little bit easier to convert into a more better and more optimal solution. So, how do I store? So, a party of customer can join the wait list. A lot of people are coming in, and suppose, and I want to. So, how do the party of customer join the wait list? There has to be something called a wait list data structure. There has to be a wait list into which a party of customers can join. So, what this means is each of the points corresponds to a function. So, what this means is we need to have a particular uh, function, like suppose join waitlist, and the party wants to join the waitlist, and I have a waitlist. So I'm just writing it in an abstract pseudocode style. I will present the proper Java code after this, but this is almost exactly equal to the code too. So I can add this to a list. Now this waitlist can be anything. Like it can be a queue. You can make it a simple linked list. You can make it an array list. So for simplicity, the most, if you see the question itself, mention this term called list. Let's choose the simplest approach. Like I can choose a list of party. Suppose I go with this particular approach, that whatever party comes in and is waiting for the table to get free, I will use the this list data structure. So this is a separate class, and suppose this all is happening in a separate class. We can just call it a restaurant waitlist data structure. This is a data structure which stores some data and performs some operations on it. The data it stores is this particular waitlist, and the operation it performs are join the waitlist. And we also need to have a constructor for this class. If you're actually from any other programming language, generally there are constructors in all kind of programming language. You don't need to worry about this too much. This is just the initialization part, how you are initializing this list. There can be various type of lists in Java, like array list is one list. There is another thing called linked list, and there are some other lists also. You can also use a queue here, but in you can actually once I explain two different kind of solution, you can actually try to use some other kind of data structure for this wait list and see if you can actually optimize this further. So I will present an most optimal solution which I know. The first solution which I'm presenting will not be the most optimal, but it will actually set the stage and it will also help you understand what the question wants. So this fulfills the first requirement, join the wait list. So now we have a data structure. We can actually call this function and on the party object, and actually the party can join the waitlist. So this kind of operation in a thing like array list, it just take order one time because we are not doing anything. Now, previously joined party can leave the waitlist any time. So you don't need to bother about here time or etc. What we need to do here is we actually need to provide a method which if we pass a party object which can and ask it to leave, that means we basically remove that particular party from the wait list. So we need to have a function called leave. So this will be the second function. So this will be the second part. This will serve the as an answer to the second part of this. And this was like the answer to the first part of this. And now how does the party leaves? Now that's where this ID comes into picture. Now for the party to leave, what we basically means is we need to remove this particular object from this particular wait list. Now it's a list. What we can simply do is we can iterate over the list and find the party which actually matches this and remove it. So there are several ways to do it. There are some inbuilt function also to do it, but just to help understand this more, what I will do, the complexity will anyway won't be affected no matter what approach you use. You can use lambdas to do it faster or in a more concise way, but not faster. I mean, if the time complexity won't change. So I basically loop over the array list. So I'm just looping like the zero. So array list is like, underneath it actually maintains an array which can be indexed by 0, 1, 2, 3. So I'm accessing the first element, which is a party or the ith element, and I can actually fetch the ID for this, and I can check if this particular party ID is equal to the ID of the party that is being passed. So that means this is the party that I want to remove. Now you cannot actually call waitlist.remove here. If you go and read, that can cause some concurrency issues. So there are various ways to resolve this. You can store the index and break out of it. And if index is not equal to -1, that means there is something to remove, and we can call this waitlist.remove index. So ultimately, what we have to do, we are actually looping over all the elements of the list, and that makes the time complexity order of waitlist dot size. So the complexity of this function depends upon how big the waitlist can be. If the waitlist can grows very large, we have to traverse all the waitlist, and then because we want to remove a particular party from the waitlist because it wants to leave, in our code, the operation will be to remove that element from the array list, and we remove it like this. We can call, if in case you have come across concurrent modification exception, I could have called this waitlist.remove inside this, but if you try doing that in Java, you will encounter this concurrent modification exception. Uh, that's not a topic I want to go into right now, but the main idea behind this code is to come up with an efficient data structure to actually perform all these three operations in an optimal way. So this particular thing is takes order of waitlist dot size. So waitlist is too long, then it will take a linear time. Now the third operation, it serves the first party which fits the empty stable size at a time. So these are some. This is again some question that needs to be clarified. So what this actually asking is to do is you will be given a table size, and you need to find the party that can fit in that table size. So what you need to do is you need to loop over all the wait lists and see if the party size can be accommodated into the given table size. If yes, remove it from the list because you can now serve it with a table. You don't need to worry about tables here, which tables are occupied, although the interviewer can certainly go into more depth, but in this particular case he didn't want to go over all those kind of details like which table are occupied. If in case you get this question and he goes into those kind of stuff, then you need to define a table which is the ID and what party is occupying it. But in this particular question, we won't go that deeper. We'll just stay at the first level of depth where we just want to implement this first three operation. Now the common approach that it asks uh, like serve the party. So that means that we need to have a serve function and which will take in table size. And what this function will do, it should loop over everything on wait list, all the parties here, and see which party actually can be occupied for the table size. So what it means is I need to loop over all the party. So this is little important function. If you get this, then the problem is simpler. So I get the particular party at the ith, and then I get the customers, and I can get the customer size. So that means how many customers are there uh, in this particular set. Or you can make it a list also. You can make it any data structure. It doesn't matter. If this is particular less than equal to size, that means we want to remove this particular party. But while you are looping over a list, you cannot remove an element from the list while you are looping over it. There are ways to do it. I think you can use if you use iterators, you can do that, but not when you're using this for loop. You can try doing this actually while doing. I will actually show you an example also why that can cause an issue. So we want to actually identify a party that can be accommodated. So that means this particular party can be identified. It can be accommodated into the table size because this particular party size is less than equal to table size. And also another important thing is we have to loop in the same way. That's why we maintain a list or a queue because in the order the customer arrives. So the party that we want to remove is this particular one, and then we can safely break out from this function. So if the party is not equal to null, then we remove this party from the list. And because so this party will occupy the table, and so this party will not be in the wait list. Now to remove it, we can actually call this leave function. We don't need to rewrite uh, anything, like removing this particular. You can simply call leave party, and we can return the party object. It's important to return party object here because you need to know which particular party you are serving or which particular party uh, got the table. And there is some other easier ways, simpler ways to code this, but this is like the naive approach. We are not using any iterators here. Iterators or some using some functional programming. I think you can write this in lesser code. But the important part here is this also takes, if you see order of waitlist dot size. So this is also linear in terms of size. This is linear in terms of size, and this is order one. Now this is the most simplest approach. And let me know if you understood what I'm doing here because it's important that you understand it here. And also remember that the question obviously does not, uh, clarify everything, and that's how they will pose it to you in most good companies if you are going for Amazon, Google, or anything. And it's you who will have to experiment and come up with something like this class and ask them clarifying questions. And that's how you will come up. Sometimes when the third point may not be clear, when was not clear, when this was initially posed to the candidate, like what exactly does it mean? Does he need to keep track of which party occupies a particular table? because if that was required, then we need to actually also maintain table ID and map a table ID to a party ID. But the interview told, no, you don't need to do that. You just need to, have a function which will take a table size and just fetch me the first party which matches the table size, and that's what we are doing here, and remove that party from the wait list. So let me know if anything is not clear in this, and I will show you that there is another better approach. There is a essentially we'll be doing the same thing, same three functions, but there is a but if we use a better data structure, a different data structure than this list, then the this particular complexity actually improves. So to go to that particular part, it's important that you understand that this particular three functions implementations are clear to you, all the data structures that we created. Uh, Let me know if there are any questions. You can type in the chat. So I will provide a code also for this question. So I have already written some code to speed up the process. So this solution uses array list. So I will just call this array list solution. You can give it any name, it doesn't matter. So this is like the exact Java code. Uh, it's basically what we are doing here is exactly what I did in the pseudocode. So just to make it easy, I actually have it written before. So now there are some differences here. If you see the class party, since we need to, I have made this field private. If you see, so here also, if you see, I have made this field private, and then actually these are called getters and setters. If you're not heard that term, you can have a look at it. So this is a general, idea to design a good class, looks like this. So ideally, you should not have a public fields here, and the variable name should also be very clear, like it should be ID and it should customer. It should reflect what actually it is storing. So you provide access to this variable not directly, but through these setters and getter methods. The idea is because these variables are actually private to this particular party. So you should not have them public, because if it's public, then any class can access these directly and could modify it and even corrupt these values. But if you have getters and setters, you have control over this particular values, what goes into the ID. Like tomorrow, so this is the general programming concept that goes into like a little bit different direction. But put it briefly, suppose I have this setter. If somebody passes a null here, I can actually throw an exception and handle it here that I don't allow a null ID. I need an ID that has that is a proper string. Or similarly, if there is some integer, I can do that. This is a common practice to design a well-designed class to have getter and setter and everything is private. That's all the same what I actually explained. This is the waitlist. It's just written in the Java style, the same thing that I explained here in text. You can just go over it for a minute and let me know if there is any confusion, if something is not clear. And here we are initializing the constructor. The leave party is again, we are basically just looping over the waitlist and finding out the index and leaving the party. And that we are removing that party from the index. Joining is very simple. We just add to the list. The adding behavior of the array list is data structure is just like a queue. We add to the end. And if you want to serve, we again loop over the list and find the first party whose size is less than equal to 7. So this is just exactly what I wrote here in pseudocode style, or exactly it is almost similar to the code, and it's like more in Java style. If you have any questions regarding this, just message in the chat. Now I will just take a minute and I will show you a better approach to solve this, a better data structure. Because here, two functions are taking linear time and one is order one. It's possible to actually use a different data structure. There is something called map and a specific implementation of map in Java called LinkedHashMap. There are similar data structures available in all different kind of libraries. Using that particular map, this particular function called leave, this can be done in order one time. So the ideal solution for this is actually to use a linked hash map instead of array list. So what happens in a linked hash map is that now here we want to leave. Suppose a party wants to leave. We are what we are doing is we have the party. We have the party's ID. What actually it's doing is we are looking over the whole list and we're finding that particular party in the wait list, and that is what is actually causing this particular linear time complexity. But suppose the idea of linked hash map is that you actually use uh, internally use a map also to store the position of the element. So suppose like this on a like a not very deeper way exactly how linked hash map works, but suppose like we also have a map which actually takes the ID and maps it to the exact uh, index in the wait list. So suppose we actually have a map. So the idea is something like this. Now, suppose we also have a map that takes an ID and maps it to index in the waitlist. Suppose we can maintain this type of data structure, one more type of map along with this. Now, when we want to do a leave, we don't need to scan for that particular index which matches this ID. What we can do is we can ask this map provide this particular party ID, and this will actually give me the index in the list. And what I need to do is just do waitlist dot remove that particular index. So that's the advantage of using a map. So map, if you are aware that HashMap in Java and in other programming language we have similar construct, it takes order one time for all this kind of operation get put. So if you just you can also even if you don't know about linked hash map, this simple idea that maintaining a separate map which maps an ID to the index will do the job, and that actually solves the problem. If you actually just maintain a map here which maps ID to the index, and any each time a party is added, you update the map because there is now a new ID and there is a new index which this particular ID gets mapped to in the wait list. Now, when you want to leave, all you need to do is perform is these three steps, and that takes order one time, and that will reduce this time complexity from wait list to order one. So even if you don't know about linked hash map, you don't need to, because all you need to do is create a map which maps the string ID to the integer index, and this is like a party list map. So I'm just writing this in pseudocode style. So you don't need to worry about linked hash map, but I will show you an implementation that uses linked hash map. And now what we can do here is here. So now a party that's added, right? Now we need to update the hash map. So we need to put this element into the hash map, and so there is some extra work to be performed in a join the waitlist because now we are maintaining an extra data structure. And what we need to put is the party ID, and we need to put the index in the of this particular element. The index is of it, since we are adding to the end of the particular list, the index will be, so if this is there is two elements, index will be minus one, this particular element. So we need to actually maintain this extra data structure. So for that we need to actually add this particular put element, put function, so that we have this particular party ID map to the index at what particular location this particular party is there in the wait list. And now this put function in HashMap, the good part is that this put and this get, these are all order one time. So this doesn't change the complexity of the part one. The part one was, even though we are performing now some extra steps to maintain this data structure, the complexity of this first operation, the join the wait list, remains order one. The size, the serve operation will still remain waitlist.size, although let's see if we can improve that. But the leave one, we don't need to perform all these steps. We can simply, fetch the from the map that we are maintaining. We can simply fetch the particular index and we can remove. And this is also, and the waitlist.remove can also be done in order one time. Now another thing that can cause. Okay, so here we are actually removing the waitlist dot remove index. Now here the waitlist dot remove index, in this case it's a list. So I think the remove part will not take order one time. Only finding the index will take one time. But that's where the linked hash map comes in. Instead, we cannot perform waitlist dot remove directly without increasing the time complexity. But the linked hash map function actually, eases all this for us. We don't need to think over all these things. But let's see how, if we maintain a separate map, what we can do. Now we have the index, and how do we remove this thing from the list? So I think we cannot, since this we have initialized this particular list to an array list, we cannot do this. We need to have a doubly linked list here. So like I will remove this constructor for ease. So only we cannot actually have this. So like you can use any doubly linked list data structure that is there. In Java, actually you initialize it using linked list, but the whole idea is to maintain a linked list instead of an array list. Because the problem comes here when I perform waitlist.remove on an array list, that will again take linear time, and that doesn't make the complexity order one. But if we have a doubly linked list, we have the particular, so in that case the map will also change again. So this is how we are progressing towards the optimal solution. Like I introduce a map logically, and we actually need to store the exact node of the linked list, which will be a party. And here we can map it to the party. So it won't be a party. So yeah, so there will be, we need to, we'll define, we will have to define some more data structure, because the linked list or the doubly linked list, what will it contain? So each element will have a party element, and there will be a next pointer. There will be a next pointer. So I'm just writing it pseudocode here, and there will be a previous pointer. So I don't suggest to go over all this type of implementation, although it's a good idea to go to actually have implement your use a doubly linked list, and to have this kind of structure, because the whole idea is actually to have a to optimize this remove operation. And what this remove operation, what this map should store in that case to optimize this is, when we give it an ID, it should actually take us to the node of the linked list. So what particular node that linked list has. So when I get this party ID, it will take me to the node of the linked list. And now since it's a doubly linked list, now when we were using an array list, the removing operation cost linear time, and that was an issue. But now we have a doubly linked list. What we can do, we have the particular node. We can remove that node and adjust the links of the previous and the next pointer to actually remove that particular thing in order one. And you can check that removing a node, so it is similar to removing a node from a doubly linked list. And that takes order one time. You can actually check it out, and it's very easy to remove a node from a doubly linked list in order one time. You just need to adjust the pointers. And so to achieve order one for join the waitlist, and to achieve order one for leave, we need to actually use doubly linked list and also this map. So you can, if you get the idea, you will be able to implement this. I will show you a Java code which actually uses a linked hash map. The advantage of using a linked hash map is it internally uses a doubly linked list to maintain the order and also a map internally. So it hides all this abstraction from you and makes it very easy for you to code. But to go over that code, the important part is that you understood this idea why we made a node, why we made a double linked list, why we maintained the node. So this map, this will map to a node, and so this is like a pseudocode. So let me know in the chat if you have any queries. I will also unmute everyone in case you can directly ask the question. Unmute. Yeah, so I think you can try even unmuting your microphone if you have any question, and or you can message in the chat. But I will also show you a linked hash map solution. So this is another solution where you manually have specified doubly linked list and manually specify a map. With, so I have a linked hash map solution already written just to save the time, but it's actually the same thing. You're ready to save all this code. I will, upload this particular video on my YouTube channel. You can all, subscribe to this, and you will be able to. I will provide the link for a GitHub also, which will have the solution to this particular thing. So I'm just checking why this error are to resolve this. Okay, this class party is causing conflict because it's in the same
Um,
package.
I have a question. So, the the um, the HashMap linked list structure, does that somehow internally handle the indexes? Because say for example, like you created a HashMap and a linked list, and then you dequeue some or you remove something from the linked list, then the indexes in the HashMap are going to be like misaligned. So um, does the HashMap linked list data structure handle
Okay.
that internally?
Yeah. So actually, I think I should specify it more. So map ID to the node. So it's not the linked list. So now, can you repeat your question again? Now I think it will be more clear. Now,
Oh
how?
yes, let's say we create a hash map in a linked list and we store in the hash map the indices of the
Yeah.
party in
So
the link.
yeah. Indices will cause issues. So that's why I'm not storing indices now. Uh, Now the indices are not there. So what I'm doing here is
Oh, I see. I
I have a
see.
doubly linked list. Now, when we have a
Uh,
doubly linked list, the concept of indices goes away, and each doubly linked list will be like a, it's like a node. There will be a head node, and there will be a next node. And what I'm storing in the hash map is a node. Then that issue will not occur. That
oh, that makes sense. Yeah.
yeah, yeah. If you store the index, that will cause an issue. You are right. But if I store the node and if I use a doubly linked list, then that will not be an issue because when I remove the node, I remove the node from the doubly linked list in order one, and I can remove the node from the map also in order one. To remove that again, I think in this particular case, to remove a node, I can, fetch the party, and from the party, node has a party and party has an ID. So I know that exact element which I have to remove from the map. So
Hmm.
does that,
Okay.
yeah, that makes it clear
Yeah.
that having a node will not have caused that issue.
Yeah, that does make sense. Thanks.
Yeah. So I will just correct
Um,
this error. Maybe this error is coming because of package name. Just give me a second. Maybe these are some ID issues, they are not that important. But I just want to make sure that you see the exact code using LinkedHashMap. So actually the party class was there in both the objects and that was causing the issue. Okay. So this is a linked hash map solution where I initialize. Okay, yeah, let's take a question. So now, yeah, I changed my. So in this should let's discuss the pseudocode because this doesn't use any linked hash map, but actually it does exactly what linked hash map uses internally.
That makes sense.
Okay. If you use these two structures like a doubly linked list and a map which maps a string to the node in the linked list, then you can,
Mm.
when a party joins, you can simply add a node to the linked list. I mean, you won't be adding a party here. You will be actually constructing a node and adding a party, and which will have a next and adding it to the end of the linked list. So these lines will change obviously. So but you can understand like what will happen here. So here what we will do, just add a node with party to the end of the double linked list that we have created, and in the so this will create a new node. So and then we map it to a node. And so when we implement the party function, we get the ID, we have the node, so this won't be required. Once we have the node, we can, delete the node from DLL, and that's take order one time. Now, sometimes now what's good about linked hashmap data structure that Java provides is, if you see, it's a lot cleaner. So linked hashmap does all of these things for you automatically. You don't need to, define a doubly linked list. You don't need to define a map like this. So if you see this code, if I define a leave function, I just need to specify, so that this is a wait map and the ID maps to the party. And if I call remove on the ID, it will remove this. The remove operation takes order one time. The join put that takes order one time. So that's the property of the linked hash map. What internally it does is exactly what we are doing here. Like the leave will actually, internally there will be a map which will have give you a node and which then we will delete a node from the DLL. But using linked hashmap takes all this complexity from you, away from you, and just provides you a remove function and a put function. Serve function remains almost similar. It will take waitlist steps. You have to iterate over the whole key set and see which party needs to be served, and therefore that party needs to be done. Uh, Let me know if you have any queries for this, or it's clear.
No, it makes sense. Yeah. No, I was just thinking if I was just wondering if we can optimize the serve like using some kind of hash map as well. But
Though the serve function,
yeah.
yeah, I mean that's a problem to think about. I think I didn't think about that. There could be a possibility to improve this. And so when the how this Google interview went is like when the candidate actually specified this, like we can use a double linked list and a map. Obviously, that's a good approach. The interviewer was happy, and the interviewer just pointed out that, do you know of any data structure that Java provides? So you don't need to actually manually do all this kind of thing.
Mm,
Fetch the load from this, and so sometimes interviewers are happy that you actually mentioned the exact approach. Sometimes interviewers are also fine that you mentioned the linked hash map and that just the job just simply call the remove put all these are order one. Yeah, I'm not sure if serve can be done in a lesser time
mm.
because
I guess
we
you could, yeah, you can maintain like some kind of array which has like the first index, which is like, oh, yeah, you'd have to have like a heap or something like that, I guess. Yeah, but if you like maintain I don't know, like the first party, um, like the first party of each size, I guess. Yeah, I guess it would have to be like a queue for each size. But yeah, okay, that makes sense. It makes sense what you're saying.
yeah, I think if we want to optimize this, then we need to find a first party that is less than equal to the given size. Not sure if
Yeah.
we can do some kind of heaps trick or something to optimize that. To find the
Oh,
first party, but we need to also ensure that it's less than equal to table size.
that's true.
Yeah, maybe that's
Yeah.
something to think about. What I can do is maybe I can, if I come up with some good approach, I will, post a video on my YouTube channel, or maybe I can do that in the next session.
That makes sense. That makes sense. Yeah, I was
Right.
thinking actually like the exact size, but that makes sense. The less than equal. Yeah, I guess that's another question you can ask the interviewer, right?
Yeah, yeah,
Like what exactly the table size or yeah.
yeah.
Okay. Cool. Thank you very much.
Thank you. Yeah, sure. So you can actually, go over my YouTube channel. You have there, my contact is there. If you have any queries, you can contact me over email, WhatsApp, and Telegram. And so
Yeah,
this is
sure.
this is my YouTube channel, and
Great.
I'm planning to conduct this every week. Take over some problem, latest into question, and provide a solution which actually worked during the.
Okay, awesome. No, it was a really good session. Thank you very much.
Thank you.
What's your name?
My name is Ronik.
Oh, Nick. Thank you very much.
Thank you. Okay. Bye bye.
All right, take it. Bye.